Окей, хорошо. Окей. Сейчас говори, что у тебя есть. Лампа, какой модель лампы есть?
Это двойной Penthode. 6P36.
6236?
Нет, 6P36.
6P36 dual Penthode. Хорошо.
It's using about 36 watt power.
Okay, using about 36.
Our system. And one heating and impulse generating to...
Потому что я хочу это дику показать. Я сейчас включу. Okay. Okay. Now, can you explain what is next to left hand side from the Penthode? Сейчас, это плитка, которая с левой стороны. Что ты там на ней поместил?
Здесь?
Yeah.
Где?
Здесь это.
Вот это, да?
Да.
Это то же самое твое устройство, которое в Америку поехало.
Okay. Bipolar power supply.
As we have made a number of approaches,
Just look inside.
and those approaches were mostly not to really try to make a working device, but to understand the concept. Methods that rules with untapped energy devices, especially toroidal Capacitor devices. So at first we came out with ferrite from the yoke, from the deflection circuitry of the TV, and we got quite significant success over there. We didn't keep up into that. I decided to go to Lithuania just to see it on my own eyes, and I've seen it. Okay. So we see the light bulb on, which is 100 watts light bulb, connected with one wire only, and is giving the light. Some of you might have an objection that we're dealing with gas ionization, or now we have a laser, which is not. The tungsten is on. The laser takes a little bit more current. Later on we're going to present what it shows on a meter. It would be very easy for us to prove that as we measure current at the grid. That means right from the outlet how much current we take and how much result do we have. Okay, you see the laser again. You cannot hold it longer because it's getting pretty hot. The same story is with the light bulb. He's trying to hold it, but it's burning his fingers. And it's not the voltage, because he's holding through the glass, but it's the current that makes the tungsten hot in it. Now he's showing the ionization of the gases, so you can differ between ionization of the gases and now you see the tungsten on. That's the best proof. Well, I don't really want you to believe that we're trying to create energy from nothing. That would never happen. Energy must have origin, must come from somewhere, and it is being utilized.
36 watts?
The energy of the sun, of photon, is free. So the energy that we don't have to pay for is our free energy. And we believe that we would be able to solve that problem. There are plenty of you guys trying to find out how the device of toroidal Capacitor works. I was excited when we did the first device with the yoke. Now, nothing longer. It's just trying different concepts. So don't ask for the schematic. We're not gonna keep any secrets. It's just another way of finding why do we really have 2, 3, 4, 5 watts at the input, and we are able to take 100 watts and more out of it. Now, the transformer that is lying on the table on the right hand side is the high voltage wire. It's a TV flyback transformer from old Russian TV. The left hand side is a dual Penthode with the small board that he's showing right now, 2 capacitors, and this is a bipolar power supply generator, which means it does have a bipolar amplifier that can sync the power unused by the load, and it could go differentially from plus to 0 and minus. The function of every or most of every one of the bipolar power supplies could be explained if you analyze KEPCO, K-E-P-C-O 1000 or KEPCO 500 power supplies and the principle of it works.
12 o'clock a.m.
Right, 12 o'clock a.m. That's how long I'm working. Now you see, depend on the left hand side, the very small board with the hint saying that's the bipolar power supply generator, amplifier, the very small transformer, and 2 capacitors. That's all. That's whole circuitry. And also, you see the green capacitor, it's 1000 picofarads, 30,000 volt capacitor.
Отлично. Там у тебя как минимум 30 тысяч вольт с ТВС выходит.
Как минимум. И вот обратите внимание, я перед этим использовал койлу, который очень много выделяет побочных колебаний наружу. Мне это очень не понравилось. Вот отключаю ноду напряжения, вот падает. Вот включаю, видишь, если, наверное?
Да, вижу.
Очень мало.
Ну, там, понимаешь, здесь есть индуктивный капелинг, так что там, правда, он...
Что мы хотели? Мы хотели закрыть?
Мы хотели закрыть что?
Чтобы не выходило бы наружу это все.
Now Aidas is gonna show the toroidal transformer. That's what you see, and the plug for the power from the outlet. Nothing in here, and then later on he's gonna cut one of these wires and connect the amp meter. So there would be 100% proof of the fact how much power we are taking. The voltage is there at 200 volts, and there will be no question about the factors. Although some of the people might have questions about the load and the quality of load, but as I say, for those who look to the part of the material that was already shown, you're gonna see the significant difference between the light bulb connected with the gas ionized only, that will be the bluish one, and the tungsten that is on. And it's gonna be trying to connect the amp meter in series between the plug from the outlet, right? So he's trying to unsolder one of the wires and prepare it for connection.
Другую плитку. Иди по проводах. Сейчас провода лежат на столе. С левой стороны. Покажи. Нет.
Вот эту. Тут
Да.
фильтр, простой сраный фильтр.
Окей. Все. Сейчас.
Now you see him connecting
Правильно. Мне надо подключиться здесь.
the ammeter,
И показать им, сколько тока берет.
and we're gonna try to measure what we have.
Нагреет.
Да, нет проблем. Нет проблем, дорогой мой.
Как обсуждали русские, тут уже первичная, частичная происходит ионизация.
Okay. Okay, check all of the wiring. Seven 7.5 milliamp, and that's how much the device takes with the high voltage transformer connected at 220 volts. And then you see the scope over there and the signal that is on the scope. So what takes 7.3 milliamp? Okay, now we have a 14. For a moment, it's in the light bulb connected to one wire only. Okay. With a transformer with the dual Penthode, with the circuitry of bipolar power supply amplifier-generator, takes 7.9, 7.3. Now, try to see the brightness of that light bulb and come back with that to the point where only the ionized gas was showed a few minutes before. Now he's switching to ultraviolet, try to see if we would be able to show the tungsten. He's using microscope camera with backlight compensation. This way everything looks dark in here, but actually the light in his room is fully on. Now he switched off, and we're trying in various points to see if we would be able to show you the tungsten. But between the flashes, you would see the tungsten going on and going off. At the same time, make sure that you look at the scope, how the scope behaves when you have a light bulb connected. Okay, right now we see the difference between 7.6 and 14 milliamps. You guys calculate, and you're gonna have your results.
What is the current that is from?
0.0.
So basically what he did is
14 times
a power plug, a small filter,
220,
bifilar transformer,
3 watts,
the board with
0.8.
the small radiator is the beta.
That's what you
power
have,
supply
okay, 3
amplifier,
watts.
And dual Penthode.
And this is the laser,
that is connected to the anode of the Penthode is connected
28,
to
0.028
1000 volts, 1000 picofarad, and then it goes to
times
primary
220,
of flyback transformer.
6.16.
За ноды, да?
So 6 watts,
Я вообще
0.16.
подключаюсь вот здесь.
It's with a heavier load.
Я это знаю. Мне анода подключена на первичку.
Now he's showing.
Этого flyback. ТВС, да. И ты там подаешь сколько вольт?
Okay, again. That's how much the device 0.04 takes if he takes disconnect the power from the Penthode. Okay, now you see the difference. 28, okay, 6 watts. 6 watts in, and the laser is on. I asked him how many watts is the laser, but he couldn't say. He says nothing is written on it. Definitely is more than 100 watts. Light bulb, which takes 3 watts. And that's your proof.
Это с розетки.
Да.
Я включаю традиционный провод. Теперь включаю нодную связь. Только осторожно, чтобы не шарахнуло бы. Включил нодную связь. Появились у нас в стилографе даже колебания. Все реально ведь. Ну, лишь бы что. А это как бы первичный этап. Ну, это очень много уже что дает. Далее сам ты видишь его. Блядь. Пальцы.
Понимаешь, то, что интересно здесь есть, что когда только ты подключаешь лампу, то увеличивается амплитуда. По всем принципам.
Так и должно быть. По самому Теслу принципу так и должно быть. Потому что нормально, хоть раз за, блядь, год, не за год, 9 месяцев, я нормально запустил вот эту штуку, блядь. Тут то же самое, что Capacitor сделал, только большой вариант. Вот.
We have in here, подожди, потому что я пытаюсь записать, если не получится. We have in here a TVS or flyback transformer with the capacitor.
TVS to A.
TVS to A. That's
It
the model.
was used as experiment. Скажи, что мы просто не до конца его нормально запустили, так как, ну как, мы запустили нормально, но мы запустили так по тестовому принципу, как он должен работать. Ну, он так не должен работать.
Basically, the way that this transformer is connected is based on the Tesla concept. Definitely we see that the power in Lithuania is 220 volts, and we've been showing the current. The current. Okay, this is
again disconnecting anode power supply, power down. It's just left heating lamp.
Right, when the cap from the anode lamp is taken out, it's not connected to flyback. That's how much is gonna
disconnecting power supply from 200 volts.
Right. Now connect it back.
Just like a little bit and lamp is heating.
Okay.
And enabling again anode power supply. Same result, and on the oscillograph you can see it. What is happening? Again, connecting lamp. Again, connecting laser to high voltage exit.
Okay, now you're not able to show the voltage right now, but voltage is taken from the power grid, so it's to 20. And we're really measuring, right,
200 volts.
200 volts, right. And we're really measuring with the clamp that you see connected in here. We're measuring the current edge, the power supply. I mean, not a, yeah, the incoming voltage to the power supply. Right. Okay. So, покажи им, чтобы они видели второй провод. Да, жестом подключен. Right. Okay. So, чтобы они видели, что ты... возьми этот второй конец прибора, покажи, что желтый провод подключен к этому. Да. Okay, so this is This is the second wire from the amp meter that is connected. It is showing the connection. Now the whole device, when it's not connected, well, I mean when the light bulb is not leading, is 7.2 milliamp. But when the cut from the anode is
taking, it's enabling impulse generator to TVS. Another state flyback. This one. When I'm disconnecting anode power supply, it's just dropping to this point where it's using lamp.
Right.
For heating process.
Ты сейчас что отключил?
Я анодное питание.
Покажи, где ты его отключил?
Я просто отключил высоковольтовую напряжение на нос.
Окей. А ты можешь подключить его обратно и снять просто провод, который за ноды подключен. Отключи вот так, чтобы им показать.
Как ты сказал?
Подключи обратно этот провод, как он был, и просто с аноды, на их глазах сними провод с аноды, чтобы они видели, как меняется ток.
Хорошо.
Подключи это там, как было.
Вот, и направляю на лампу. Подожди, обои ставлю так, чтобы видно было.
Да, окей. Right. Okay, now what he's gonna do is he's gonna take the wire from the anode.
Это очень плохо для меня. Не надо такие послушки взять, что-то такое вроде. У меня шарак.
Okay. He's gonna try to take the wire from the anode.
Wait a second.
Out to show how much the device would take if because we have a device connected, the high voltage is there.
Yes, the voltage again is here. I'm trying.
Okay. Now, what he's trying to do is not disconnect the device, to disconnect the wire from the anode to show how much the device is taking. Okay. This is how much the device is taking power from the grid when the anode
is disconnecting. There's nothing.
Right,
here.
And now you see the light bulb is not leading. Okay, right. Now let's put it back, the wire back.
It's not so easy.
Это 400 вольтов, чего ты хочешь?
Там в импульсах больше.
Ага.
Как бы криво надел, не надел.
Okay, so now we have a total. Okay, connected the light bulb, but it looks like right now it's taking more current.
Yes, I see.
Why is that? Can you check what's going on? Now it's taking more current.
Because it's too close to high voltage, на высокий выход вольтажа.
Okay.
Просто ТВ влияет на него.
Right. Okay. Now we have a 16, 14, 16. Okay. The tungsten is definitely hot. А у тебя есть сам провод, вольфрам, провод, который из этого поломанного, чтоб ты подключил только и показал, что вольфрам.
Да, есть.
Да. Возьмешь в кусачки одной стороной и подключишь, чтобы им показать.
Я понимаю, что кусачки не убирать, ему надо индуктивные связи, я как конденсатор. Я возьму через резиновые перчатки, никто не получит. Преобразование на нужном амплитку, еще чтобы еще горело бы два провода, чтобы два провода. Как бы у меня все готово. Даже Барселона когда создала катушку, я могу показать, индуктивность и емкость в одном. Управление блок, как оно не на лампе делает, она делает, значит, оно там обсуждали.
Да, ты не послал это.
Когда мне ясно было месяц тому назад, там первичный блок я постепенно собирал, мы говорили, вот, это L и C в одном. Вот прикинь, женщина, сколько дошло, 40-50, да не важно, прекрасная женщина, уважаю, блядь, не знаю как.
Да, женщинам это очень необычно, что такое.
Говорю, ну уважаю, я ее это не представляет как.
А она по образованию кто?
Физик.
Физик. Я тебе скажу так. Физики, какие они бы ни были, включая меня.